So we're going to look at a problem where an investor is presented with a choice of two investments. They could either invest in a convenience store or they could invest in a sports store. All right, it says each choice requires the same initial investment and each produces a continuous income stream of 8% compounded continuously. The rate of flow of income from the convenience store is f of t equals 14,000, the rate of flow, so that's my derivative. And the rate of flow of income from the sports store is expected to be g of t equals 12,500 e to the 0.05 t. What we want to do is we want to compare the future values of these two investments to see which one's the better choice after 10 years. So both of these are going to use this continuous income stream formula. So we find that with the future value equals e to the RT, our integral from 0 to t, f of t, e raised to the negative RT dt. So for the convenience store side, and actually for both of them, the R is going to be the same, 8%, or decimal 0.08, and both of the big T's are going to be the same for 10 years. So for the convenience store then, we're going to have the future value is e to the 0.08 times 10, that's my R, big T, from 0 to 10, where I see f of t, I plug in my function, which is 14,000, and then I follow it up with the e to the minus r. Again, my rate is 0.08, and t is my variable of integration. So from here, what I'm going to do is find the antiderivative and then start away plugging everything into my calculator and get an answer. So I'm going to go ahead and just multiply this out to simplify it a little bit. So I get 0.8. I have times this 14,000. When I take the antiderivative of this e to the negative 0.08t, we still get e to the negative 0.08t, but then remember when we're doing the antiderivative, we have to divide out the chain rule piece, which is the negative 0.08. So in other words, this is back where we say the antiderivative of e to the kt is 1 over k e to the kt. So that's all I'm doing, is bringing the negative 0.08 to the bottom. And then of course I'm going to evaluate this from 0 to 10. So now we just start plugging things in, and what I would do is make this a little easier, meaning I would get all the constants out front. So I'd get the 14,000, the e to the 0.8 over negative 0.08, and then that way the only thing I'm evaluating is this e to the negative 0.08 times 10, and then minus e to the negative 0.08 times 0. Wrong button. In other words, I'm doing my limits of integration. And so hopefully you can get all that plugged into a calculator, and it says round to the nearest integer, and you should get this value. Be careful when, if you're using a pretty good TI calculator, you could probably just put this in one sweep. If you're doing pieces, just be sure you're keeping a lot of decimals. Otherwise, you might end up with something you know, like $1 off because due to your rounding. All right, so this is the convenience store. The sports store, if you remember, up here, so when I write it again down at the bottom, give me this function. So this is what's going to be plugged into my formula for the function. This one just gets a little weird, so what I'm going to do is I'm going to rewrite my formula again just so you can see where everything's going. 0 to t, f of t, or in this case the sports store was g of t, e to the minus rt dt. The reason that this is weird is because my g of t already has an e in it, and that normally throws students off. So my r is 0.08, my t is still 10, 0 to 10. My g of t was 12,500 e to the 0.05 t. Now I'm to this piece right here, so I just copy it, which is e to the negative 0.08 t dt. So this is typically the part that throws students, is because you got two e's, you just happen to have an e in your function, and that's okay, because we remember when we multiply and the bases are the same, then we simply add the exponents. So I'm going to go out front here and get a whole bunch of this junk out front, meaning I'm going to put the 12,500 out front. This, of course, again is going to be e to the 0.8. And my integral from 0 to 10. So what I have left is this piece right here. And as I mentioned, when the bases are the same, you add the exponents. So I'm going to add a negative 0.08 t dt. And now I'm to the point I can actually get my function to look in a way that I know what to do with it. So 0 to 10. I subtract these and I get negative 0.03 t dt. So all I did was subtract that. Now I'm home free, because this is just like the first part, where I'm going to have 12,500 e to the 0.8. My evaluation here is going to be e to the negative 0.03 over, and I'm going to stick this outside, negative 0.03. That's the k part of my formula. And then evaluate it from 0 to 10. If I do that, you should get, well, let me write it just one more step to make sure you got this evaluation down. So all that's just going to go in a calculator. This, because in fact I forgot to put my t there, this is going to be e to the negative 0.03 times 10 minus e to the negative 0.03 times 0. So, sorry, that's pretty messy. So once again, I'm evaluating at 10 and then at 0. And you should get something like 24,000 or $240,342, which certainly ended up being more than the convenience store, so this is the better investment. But again, probably this one is tricky for most, because of this one step right here is not knowing what to do when you have two e's. This is a continuous and constrained.